This conference will now be recorded.
Hey, hello everyone. Welcome to Rushi Technologies. In today's session, we'll start discussing about Docker. And first, before we discuss about what is Docker, why we will use Docker, and what is Kubernetes, and why we are going to use Kubernetes, and how we will be using Docker and Kubernetes for building and deploying applications. Right. First, I would like to walk you through the syllabus of Docker and Kubernetes. So next 2.5 months, approximately 2.5 months, it close to 3 months. So we are going to discuss about this Docker and Kubernetes in a detailed way. So first, if you know what you are going to learn in the next 2.5 to 3 months, right? Then you will get a complete picture about the scope the scope of this training, Docker and Kubernetes, right? How much in depth we are going to learn, and where we will be using all these things, you will get an idea. But before we start Docker and Kubernetes, in order to learn this Docker and Kubernetes, first you should have the basics very strong. First you should have the basics very strong. So first let me tell you the prerequisites to learn this Docker and Kubernetes. So here the basics are a fundamentals, you should be strong, like Linux, and also SCM tools, like GitHub, because again we are going to maintain our application code in the SCM repositories, and we will be writing the Docker files, and we are going to maintain the Docker files and Kubernetes manifest files in the version control system. So you should have a good knowledge on this SCM tools also, in order to be expert in Docker and Kubernetes. At least you should have some knowledge on the build tools. So we have various programmatic languages. We have various programmatic languages like Java, Python, Node.js, and there are some build tools for building that applications. And again, whatever applications developed by that application team, right? We are going to build those applications packages, and again we are going to build the Docker images or container images out of that application code, along with required softwares and configurations. Then we are going to run that applications as a containers. So in order to build the application and its dependencies, you should be good in some build tools like Maven for Java application, npm for Node.js application, pip for Python application, like that. And again, here we will be deploying Java based applications, right? You should be good in web servers and application servers concepts. Web servers and application servers concepts, like web servers like Tomcat, right? Example. Similarly, we are going to learn this Docker and Kubernetes, but again we need an automation. Instead of manually building our application packages, and instead of manually building a container images and pushing those container images and deploying them in Docker or maybe in Kubernetes, instead of manually, we are going to have a pipelines, CI/CD pipelines. So we are going to integrate this Docker and Kubernetes along with CI/CD automation. So you should be good in Jenkins, or maybe any other CI/CD like Jenkins, or maybe any other CI/CD tools. And again, we are going to use servers to to build our container images, and we are going to use the servers to set up the Docker, or maybe we are going to use the servers to set up the Kubernetes clusters. So at least you should be good in one cloud computing concepts and cloud. At least AWS. In AWS, at least you should be good in EC2, VPC, IAM, like that. So if you know at least all these components, right, in a detailed way, then you can, along with these tools, if you know Docker and Kubernetes in a detailed way, then you are going to get an end-to-end scenarios. You are going to implement end-to-end CI/CD pipelines. We are going to, at the end of the Dockers and Kubernetes, we are going to set up a CI/CD pipeline to build and release our applications as a containers and deploy them in a Kubernetes clusters using CI/CD. Right? So at the end of the Dockers and Kubernetes, you will be in a position to understand this complete picture. So at the end of this Docker and Kubernetes training, we are going to implement end-to-end CI/CD with Jenkins, ArgoCD, GitOps workflow. Right. So here now we are going to focus in this Dockers and Kubernetes. We are focusing on this area, Docker. What is Docker? How to use Docker? How we can build our applications and how we can release our applications as a containers. So we'll discuss about what is Docker, what is image, what is container, what is image registry. We will discuss in a detailed way. I will walk you through the Docker syllabus so that you will get an idea. And we are going to focus now on Kubernetes, how to release those applications in a Kubernetes clusters, like what is Kubernetes, how to set up a Kubernetes clusters, right? What is pod deployment, config map, secrets, istio, ingress rules, volumes, like that. But here, at the end of the day, as a DevOps engineer, you are expected to know end to end, not only particular tools. Not only particular tools like only Docker, only Kubernetes, there is less opportunities. But people are expecting, I mean to say, the organizations are expecting the Docker and Kubernetes along with the other tools, but more demand is there who are good in Dockers and Kubernetes. Because nowadays, if you take any application, any application that we are going to build, they are following a microservices architecture, and the Docker containers is the best way to run our microservices. So in order to build, in order to deploy any enterprise applications now, people should be strong in Dockers, Kubernetes, like that. So here, at the end of the day, you should be good in Docker and Kubernetes. But if you only Docker and Kubernetes also, if you only know Docker and Kubernetes also, along with this, you should be good in some other tools. Suppose if you see, this is what we are going to implement at the end to end. The moment developers will write the code, the application code, the moment will write the moment developer will write the code, they will verify the code, and locally they will push the code to the SCM repository. But if you don't know what is SCM, how to create a repositories in SCM like GitHub, what is branches, what is repositories, right? How to pull, how to push, again, if without Git knowledge you don't understand this, again, without understanding this CI/CD concept, you don't understand how to implement the pipeline, right? So here we are going to write a pipeline, like whenever there is a change in the source code, that pipeline, that CI/CD pipeline will take the latest code from this SCM repository, and it will try to compile the code, execute the unit test cases, check the code quality, code coverage using tools like Maven, SonarQube. Again, with the help of Docker, right? We are going to build a container image, and we are going to scan that container image for security vulnerabilities. Then we are going to push that image to some artifactories, and then again with the help of Jenkins, directly we can deploy that application in a Kubernetes clusters by creating a Kubernetes resources. Otherwise, you can follow the GitOps model using ArgoCD like that. But in order to understand this end-to-end flow, if you wanted to get an idea before starting this Docker, you should be good in all these components. So as part of DevOps with AWS course, as part of the DevOps with AWS complete program, we already discussed. We already discussed the Linux in a detailed way, Linux shell scripting, SCM tools, build tools, and again code quality, code coverage tools like SonarQube, Artifactory tools like Nexus, JFrog, and also web servers, application servers, configuration management tools like Ansible, CI/CD tools like Jenkins, cloud like AWS. So along with this, you should know Docker and Kubernetes. Now let's get into the course curriculum, what we are going to discuss as part of this Docker and Kubernetes in next 2 to 2.5 months. So first we'll start with the introduction of Docker. First of all, what is Docker? Is Docker is an alternative for any other software that we have already learned in DevOps, or is Docker is replacing any other tools that we have learned? No. So Docker itself is a separate category. So there is something called containerization tool. So first we'll try to understand what is Docker, what is containerization, and what is virtualization. What are the challenges? What are the challenges of building and deploying application in a virtualized deployment or virtual machines? And what are the advantages of building and deploying applications as a containers? So the most popular containerization tools. What containerization tools we have, right? With respect to containerization tools, what is Docker? What is the advantages of using Docker? Again, how to set up the Docker, how to install Docker, right? And again, we'll try to understand Docker architecture. So in a detailed way, if you wanted to learn this Docker, you should be good in Docker components. What do you mean by Docker client? What do you mean by Docker daemon? What do you mean by Docker registry? Right? You should be good in the Docker architecture. And again, in Docker, we have a various Docker resources or an objects like a Docker image. So Docker image is different and the machine images are different. So in cloud like AWS or Azure or GCP, when you are creating a virtual machines, we are going to use some image. But that machine image is like it's a package of operating system. But here Docker image is it is not OS except OS like whatever softwares and configurations you need for your application. Along with that, your application code and application configurations and middleware softwares that is required to run except OS. So we'll try to understand what is image. We'll try to understand how to build a container images, how to build a container images for various applications like a Java applications, Python applications, Node.js applications. We'll understand and how to store that images in a Docker registries and how you can share those images and what is containers, how to create a containers and Docker registries and repositories concept. And we'll try to understand the Docker flow, Docker workflow. And again, when we are going to work with the Docker, you are going to use so many commands like Docker build commands, Docker login, Docker push, Docker pull, like that. There are so many commands, Docker CLI, in order to work with the Docker images, containers, networks, values. You should be good in Docker commands. We will be discussing about Docker commands in a detailed way. And again, most important component is this Docker images and Docker files. So we will be discussing about what is Docker image, what is Docker file, how to write a Docker file, again, how to write a Docker file, again, the various instructions that we will be using in a Docker file, like from run, CMD, entry point, like that. Various instructions we can use in a Docker file, how to write a Docker file, what is Docker image layers, and how to create an images, again with the industry best practices. So you are going to write a Docker file, but that should be whatever Docker file you are writing and whatever Docker image you are creating for your applications, it has to follow some standards. So we'll try to understand the best practice and the standards that you can follow while working with the Docker file and creating a Docker images. This Docker file concept itself we will discuss around 4 to 5 sessions, so that you can understand how much in depth we are going to cover about Docker file. If any application team, if any application team reach out to you to create a Docker file for their application based on their requirement, you can easily write a Docker file and build a Docker image for them. That much extent we will be covering here. And also I will take some sample applications. We'll see how to build and deploy Java based applications, Python applications, Node.js applications as a containers. And also if required, we can set up databases also as a containers. We'll see how we can deploy Mongo database software also as a container, and how application deployed as a containers can talk to the database deployed as a container using Docker networks, and what is Docker volumes, why we need to use Docker volumes, and the Docker registry. Registries are artifactories where we can store these Docker images, Docker packages. So we will see how to pull the images to the public repositories and private repositories like ECR in AWS also. And again, in detailed way, we are going to discuss about Docker networking. Docker networking, like what is networking in Docker, different types of networks like bridge network, host network, overlay network, and how containers deployed in a system can communicate with each other using Docker networking, networking related commands. And again, values. We'll try to understand how we can use a values for stateful applications that we are deploying in a Docker as a containers. What is the use of values? Why we need to use values? Again, we'll try to create a CI/CD pipeline for building and deploying application as a container instead of manually building a container image, instead of manually pushing the container images to the Docker repositories, and instead of manually pulling that images and running that as a containers in the Docker systems. With the help of Jenkins CI/CD, how to create a pipeline for automating this workflow, we'll discuss. And again, we will discuss about Docker Compose and Docker Swarm. But nowadays, most of the people are not using Docker Swarm, that container orchestration. Most of the people are going to use Kubernetes. That's why I'm going to provide this Docker Compose and a Docker Swarm videos as a pre-recorded sessions. Only this Docker Compose and Docker Swarm only pre-recorded sessions, but all about topics will be live and interactive sessions. Once we know about this Dockers, there are a lot of challenges with the Docker. Docker is only containerization. We will understand what is containerization, what is container orchestration, like that. But why container orchestration is required? And with respect to container orchestration, what is this Kubernetes? So Kubernetes is like a mandatory now. Whether you are a developer, whether you are a DevOps guy, whether you are a database administrator, right? So here you should be strong in Kubernetes. So here, as part of this Docker and Kubernetes training, we are going to discuss Kubernetes in a detailed way. The Kubernetes itself may take around 40 sessions. You can understand how much in depth every day, 1 hour 40 minutes to approximately 1 hour 45 minutes every day session. And almost 40 sessions we will be discussing on Kubernetes itself, each and every component in a Kubernetes in a detailed way. So if you attend this Kubernetes sessions, if you practice this Kubernetes session, you can easily go for a CKA or CKAD certification also if required. So we are going to cover all the syllabus that is asked in certification exams like CKA, Certified Kubernetes Administrator, or Certified Kubernetes Application Developer. Right? So as part of this Kubernetes, we'll be discussing about what is Kubernetes, why we need Kubernetes, what are the advantages of Kubernetes. Again, the Kubernetes architecture. the Kubernetes architecture in a detailed way, like what is master, what is worker, API server, schedulers, control managers, like that in a detailed way, and how to set up a Kubernetes cluster, like what is a single node Kubernetes cluster, what is multi-node Kubernetes cluster, self-managed cluster, fully managed clusters, the differences between all of them. And again, the Kubernetes resources are objects like Kubernetes namespaces, pods, deployment services. Like again, understanding about pods, single container pod, multi-container pods, right? Pod life cycle, right? How to debug and troubleshoot when you are deploying your applications in a Kubernetes with the help of kubectl, CLI, and Kubernetes services. What is Kubernetes service? Why do we need Kubernetes services? Again, different types of services in Kubernetes like cluster IP, node port, headless. And also in Kubernetes, we have something called deployments, Kubernetes deployments with the different deployment strategies, with the different deployment strategies like rolling update strategy, recreate strategy, and again, what is blue-green deployments, what is canary deployments. And also in Kubernetes, when you are deploying some applications as a containers, we are going to use something called resource request and limits. What is that? What is the use of this resource request and limits? And again, this horizontal pod autoscaler, this horizontal pod autoscaler automatically increasing and decreasing the pods based on the demand or a load. And again, the Kubernetes config maps and secrets to configure the applications running in a Kubernetes from outside. And again, health checks, how you can perform the health checks on the applications running in a Kubernetes pods using liveness probes, readiness probes. Again, Kubernetes daemon sets and persistent storage. Like again, in Kubernetes, what is volume, what is persistent volume, ephemeral volumes, persistent volume claims. Again, static values, dynamic values using storage classes. And again, in Kubernetes, in order to deploy the applications, stateful applications, we have a stateful set. What is stateful set? What is the difference between stateful sets and deployments? And how the stateful sets differs from deployments, we'll try to understand. And again, in Kubernetes, scheduling. If you wanted to schedule your pods on a particular nodes in a cluster, we have some concepts like node selectors, node affinity, pod anti-affinity. Again, node maintenance like a taints, tolerations, drain, cardon. And again, network policies. The way in servers we have a firewalls will control incoming and outgoing traffic to the machines. But within the machines, you are running your applications as a containers in Kubernetes pods, right? How you can apply the network policies to restrict pod to pod communication using network policies. Again, how to set up a fully managed Kubernetes cluster in AWS like EKS. What is cluster auto scaling? How different it is from pod auto scaling. And again, ingress rules to route the traffic to the services in the cluster. And again, Kubernetes access. When we are working as a team, we have a shared Kubernetes cluster, but how you can restrict the access to the Kubernetes resources? Like developers should have limited permissions in the cluster. DevOps guys should have a more permissions in the cluster, like limited permissions using RBAC, like role binding, cluster role binding. Again, in Kubernetes, we have something called Helm, package manager. So Helm is a package manager for Kubernetes applications. We'll try to understand what is Helm, why we need Helm to deploy applications in Kubernetes, what are the advantages of using Helm over Kubernetes YMLs, how to create a Helm charts, and how to deploy applications in a Kubernetes using Helm. And again, nowadays, if you go and work on any enterprise applications, there is something called service mesh to control the traffic management in Kubernetes, security in Kubernetes, right? So service mesh, what is service mesh in Kubernetes? With respect to service mesh, what is Istio? And using Istio, how we can control the traffic to the services deployed in a cluster, right? We'll try to understand about Istio. And again, log aggregation and log monitoring using ELK, Elasticsearch, FileBit, Kibana. How we can set up a this log aggregation tools to central, collect the logs from various places and aggregate the logs for application teams to troubleshoot and debug the application issues at a central location like Elasticsearch, FileBit, Kibana. And again, monitoring the Kubernetes clusters and applications deployed in a Kubernetes clusters using Prometheus and Grafana. And again, at the end, we will try to implement a CI/CD pipeline. CI/CD pipeline, building a CI/CD pipeline with Kubernetes using Jenkins and ArgoCD, GitOps flow. So here, this end-to-end flow, right? So we'll try by end of the Kubernetes training, you should be able to understand what is Kubernetes, what is ArgoCD, what is pods, deployment services, what is this ingress controllers, ingress rules, how end user traffic will come to the applications deployed in a cluster. And again, instead of manually building and releasing the applications into this cluster, instead of manually building and releasing the applications into this cluster, right? How we can automate this entire process using CI/CD pipelines. So first we will be focusing on tools individually. First we will focus on what is Docker, the various concepts in Docker. Later we'll try to understand what is Kubernetes and various components in Kubernetes. Once we are familiar with this, we will try to implement an automation for building and releasing applications into the Kubernetes, the flow, CI/CD flow. So this is what we are going to achieve at the end of this Docker and Kubernetes sessions, right? So in order to learn all these components in a detailed way, not like what is what. So in order to learn all these components in a detailed way, it takes approximately 2.5 to close to 3 months. So you should attend the sessions regularly, because one session is depends on the previous session. Suppose tomorrow, I'm just giving an example. Suppose I am going to start tomorrow what is Docker, what is difference between containers and virtualization, what are the advantages of containers, right? So without learning that, if you try to attend the next session, maybe related topics will come, that time you will get confused also. So you have to make sure you are attending the live sessions. If you are not able to attend the live session because of some meeting, office meeting, some personal work, we will be giving access to the recording. So you should go through that recording and continue the next session, attend, watch that recording, then you attend the next session, so that you will have a clarity and you will have the understanding about the next concepts also. So this is the overall syllabus that we are going to discuss as part of this Docker and Kubernetes sessions, right? So now with this syllabus introduction, let's get into the Docker. So what exactly this Docker, why this Docker came into the picture, why this Docker came into the picture. So what is exactly Docker? Now, in order to understand Docker first, before we understand Docker, first you have to understand how we used to build, how we used to release our applications or softwares before this Dockers and containers, past, past and present deployment approaches. So Docker is a containerization tool. We'll try to understand in a detailed way. So Docker is a containerization tool. Docker is a containerization tool or a containerization platform or software, whatever you call it. Docker is a containerization tool or a containerization platform or a software. Using Docker, we can build, we can ship, we can build, we can ship, and we can run any application or software as container, or a containers. So this Docker is one software. Using that Docker software, we can build, we can ship, and we can run any other applications or softwares as a containers. So first of all, what is containerization or what is container? So forget about Docker containers or application container. In general, what is container, guys? In day-to-day life also we'll use containers. Forget about Docker containers or application containers. Just in general, the general concept. So what is container exactly? In day-to-day life also we are going to use containers. Containers are used to store something or carry something. We are going to use containers to pack. We are going to use the containers to create a package. We are going to use the containers to package or create a package with whatever stuff you need. So if you are trying to move, if you are trying to move something from one place to another place, suppose let's imagine currently you are working in Bangalore, and you wanted to relocate, you wanted to move from Bangalore to maybe Hyderabad. So you are going to pack whatever you wanted to move from one place to another place. You are going to pack everything into a container so that it is easy for transferring, it is easy for moving from one place to another place. So if you are packing whatever you wanted to move from one place to another place in a container, if you are moving that as a container, do you think you will miss anything in that package? Do you think you will miss anything? Yours, whatever you wanted to move, if you neatly create in a if you neatly package in a container, do you think you will miss something in that process of moving from one place to another place? No, right? So everything you have neatly packaged into a container and you are shipping that container. Similarly, whenever you are deploying your applications, that application requires so many things. You need application code, not only just application code. You may need to have a required middleware softwares like Java software, Python software, and maybe some dependencies of that application, some configurations of that application. In order to run your application requires so many things. Application code required softwares, that middleware softwares and configurations, and dependencies of that application. So if you are trying to deploy applications in a different servers, if you are deploying your applications in a different servers like dev servers, production servers, QA servers, like that, in each and every server where you wanted to deploy your application, you need to make sure that application code should be there, that application software should be there, dependencies should be there, configuration should be there. Suppose you are missing something. Suppose you have an application code, but the required configurations is not updated in that server. Suppose you have a configurations and application code, but you have not installed the proper versions of the required software. Do you think that application will work as expected? No, there will be inconsistency. There will be inconsistency. So this is where this containerizations came to the picture. This is where this containerization tools. This is where the containerization tools came into the picture. So here, using this containerization tools, using this containerization tools like Docker, right? We can build a container image, one package like a tar file, zip file, like that only you can assume as of now. So using Docker, you can create one package. We call that package as a Docker image or a container image with all the required softwares, configurations, dependencies, and application code together. With whatever you need, using containerization tools like Docker, you can create a Docker packages or a container images with all the required softwares, configurations, dependencies, with application code, so that wherever you wanted to deploy that application, you can use that package and run that software as a container. So basically, what is Docker container or Docker container here, right? So this container basically Container contains everything. Everything means in the application standpoint of view, container contains everything like application and its dependencies and configuration settings or configuration files and required environment variable and middleware softwares like Java, Python, whatever, like required softwares to run that application. So this container contains everything like application, its dependencies and its configurations and environment and the softwares to run any piece of code, right? So container contains everything which is required to run your application or a software. So using Docker, we can build a container images using Docker. Docker is one containerization platform, containerization software. So using Docker, we can build a container images. Images is like a package. Images is like just a package. Using Docker, you can build a container images with required application, dependencies, configurations, and softwares, and we can store or we can push. We can store these images at a central place. At a central place, we call it as an artifactories or a registries. Right? We can store these container images at a central place, which means we can move. So using Docker, we can build a container images and we can push or we can move these images to a Docker registries or artifactories. Then wherever you wanted to run, wherever we need to run or we need to deploy, we can just pull that image and create a container so that our application will up and run. This is at high level Docker. But if I directly go to the Docker, you may don't understand the advantages. So first let's understand before Docker how we used to build these applications or softwares, and what are the challenges that we had with building and deploying our applications in a traditional deployment or a physical deployment. What are the advantages of using virtualized deployment, and again what challenges we have in the virtualized deployments, what is containerized deployments, we'll try to understand first. So past and present deployment approach. So in early 80s, and early 90s, we used to follow this traditional deployment model. Or a physical deployment. Let's say you guys already know, in order to run any application or any software, first you need a hardware, you need an infrastructure, that servers, you need a physical servers or a bare metal servers or a physical servers. Maybe you are using on-premise environment. In early 80s 90s, we used to have an on-premise environment where we used to have a hardware. So in order to deploy any application or a software, first you need a hardware, you need an infrastructure. In early 80s or 90s, we used to follow this approach. We have a server, we call this as a physical server, or we call it as a bare metal server. So this is our hardware. Like every server comes with some kind of a capacity. This is our infrastructure, this is our hardware, like that will comes with some CPU, memory, and storage, like that. So in early 90s, early 80s, we used to follow this approach. We used to have this server, physical server or a bare metal server, in this traditional deployment model, traditional or a physical deployment, traditional or a physical deployment model. We have some challenges, we have some drawbacks. So what is that drawbacks? First we'll understand how this used to work. Let's imagine this is your physical server or a bare metal server. This is not like our traditional laptops or a desktop, like IBM server, Dell servers, that bare metal servers. It is not like our desktops or laptops. Basically, these type of server blades. I am talking about these type of servers. Like this might be manufactured by Dell, or this might be manufactured by IBM. These physical servers are bare metal servers. So this hardware comes with some kind of a CPU, memory, storage, like that. Let's imagine this server has maybe 32 CPU, 32 core CPU, and this server has maybe 64 gigabytes of memory. Maybe let's imagine this server has some storage. Storage means a disk. Memory means RAM. Memory means RAM. Storage means a disk. Let's imagine we have some server. Let's imagine this is the compute capacity, memory capacity. Here, on top of this hardware, we need a OS, operating system. We need to have a OS. That OS can be Windows OS, Linux OS, because this hardware don't understand any human readable language. This hardware don't understand softwares. This hardware don't understand like Java, Python, like that. So this hardware will understand only binary code, zeros and ones. So here we need an operating system. We need an operating system that is going to interface the software with hardware, right? In this operating system, we have something called kernel. Right? So the kernel is like a heart of the operating system. That kernel is going to translate or interpret the human readable instructions into a machine understandable code, right? So we need a OS here. Without OS we can't work with this hardware. So we have a various operating systems like Windows operating system, Mac operating system, Linux. In Linux, various distributions like Red Hat, CentOS, Amazon Linux, Ubuntu, Fedora, like that. So we need an operating system. So on top of this operating system, you can deploy your application. Let's imagine your application team. Your application team means a development team. Let's imagine your application team developed some code. Let's say your application team developed some application that can be a static web application, or that can be a dynamic web application, or it can be a API based application. They have developed application, and let's imagine they are maintaining that application code into a SCM repository. They're going to maintain that application code into a SCM repository. Imagine this is a Java code, Java application, Java web application. Now, using builder tools like Maven or a Gradle, you will build a Java application package. This application package, like jar, var, in case of Java, I'm just taking example here, Java application. Let's imagine this is my application, but here we can't directly run this application without required softwares, without required middleware softwares, without required configurations and dependencies. You can't run this application. So before running that application, before deploying that application in this system, you need to configure this system. You need to configure this system with required softwares, required configurations and dependencies. Then you can deploy. Suppose, just to give an example, since it is a Java based dynamic web application, here we need a softwares like Java software, that middleware softwares. We need a softwares. Just I'm taking example Java. We need a Java software, and again we need a application server softwares like Tomcat, and maybe some kind of a configurations, Tomcat configurations or settings. Maybe you need to update some settings file like server.xml or maybe Tomcat users.xml, and you may need to set some kind of a required environments here. Then only you can run this application. Let's imagine this is where you have deployed required softwares and configurations. Then you deployed your application. Then you deployed your application. Now, this is how we used to follow in a physical deployment or a traditional deployment. But understand here, imagine this is the capacity of the system. Imagine this is the capacity of the system. But the application running in the system, the application or a software you deployed in the system, this is not using that much capacity. Let's imagine this application is using, let's say, just 4 CPU, maybe maximum 8 GB RAM, 8 GB memory. So this is the capacity of the server. This is the capacity of the server, but the application deployed in the system is using only this much. So what is the problem with this now? Our hardware is so much costly. Our servers, the infrastructure, the physical machines, that hardware is very costly, and you are wasting the hardware resources or a system resources like CPU, memory is not used to full extent. So you are wasting your hardware resources. You are wasting your hardware resources or a system resources here. So this is the capacity of the system, but the application or a software deployed in the system is just using this much. You are wasting your system resources. But you may have a doubt. You may have a doubt. Sir, why I need to waste this hardware? Can't we run multiple applications in a same system in same OS? Like that, you may have a doubt. Sir, why can't I run multiple applications like this in the same system, in a same OS? Imagine this is one application. Similarly, why can't I deploy one more application? Maybe if this application is using this much, okay. Maybe again I can run one more application, that can be Java application, Python application, or database application, or CI/CD application, that doesn't matter. Why can't I run like this one more? Like that, you may have a doubt. But understand here, there is a concept called a kernel in this operating system. In this operating system there is something called kernel. In that kernel again we have something called namespaces. In this OS, in this kernel there is something called namespaces like user space, network space, storage space, like that. User area, process area, network area, storage area, like that we have some spaces, right? Common. Suppose if you deploy multiple applications in a single OS, multiple programs, multiple softwares or a multiple programs, if you are deploying in a same OS, if you are not isolating, if you are not isolating that each application from other applications in that user space, process space, network space, like that, all are sharing the same space. Like you are going to a PG. Let's imagine you are going to a PG, you have a share room, 3 share room, 4 share room, like that. Imagine this is your OS, like a room, and where multiple people are sharing that same room, sharing the same room. So this is common. But in this OS, in this OS we have something called process space, network space, storage space, like that. If each process deployed in that OS is not isolated from other process in the user space, process space, network space, like that, if one application is causing the issue, if one application is causing the issue in that operating system, in that user area, or a process area, or a network area, or a storage area, is the other application that is also sharing the same user space, process space, is going to impact. If you are not isolating and then keeping multiple applications in the same OS, it is like you are keeping multiple people in the same room. If one person is impacted, right, is other persons also going to be impacted if there is no isolations or boundaries, like that? Yes. So similarly here, if you are not isolating, if you are not isolating each process or each application from other applications are processed in that same OS, from user space, network space, storage space, like that, then one application causes the issue in that kernel, other applications running on the same kernel in the same user space, process space also going to be impacted. So if you are not isolating, you cannot run. It is not recommended to run. It is not recommended to run without isolation. But if you are not isolating, you can't run. If you are not isolating, you can't run. Right? So if you don't run, you are wasting your resources. So this is the challenges with the physical deployment or a traditional deployment. So to overcome this, in early 2000, there is a concept called virtualization. Virtual machines concept came into the picture. Virtualizations are a virtual machines concept. So in virtualizations or virtual machines, how these problems are addressed, we'll try to understand. Now let's imagine in case of virtualization or a virtualized deployment, again we have a hardware, again we have a server like this. But instead of directly deploying application in this physical machine or a bare metal machine, with the help of hypervisors, we are going to create a virtual machines. We are going to create a virtual machines with the help of something called hypervisor. So here you are virtualizing your hardware using hypervisors. You are creating a virtual machines and you are doing a hardware level isolation here. So here this virtualization or a virtualized deployment came into the picture. Let's imagine this is your application. That's it. Okay. Imagine this is your application. Okay. But now here there is a concept called virtualization came into the picture. So here with the help of something called hypervisors, something called hypervisor. So you are isolating your hardware with the help of this hypervisors. With the help of this hypervisors, you are creating a virtual machines. So with the help of hypervisor, so this is the physical server or a bare metal server. So here virtualization or a virtualized deployment we call it. Virtualization or a virtualized deployment we call it. So using this hypervisors, we are going to create a virtual machines on top of this physical machine. On top of this physical machine, you are going to create a virtual machine. So while creating a virtual machine, you are going to allocate, the hardware resources. You are going to allocate the hardware resources for this virtual machine. So this is the physical machine or a bare metal machine or a physical machine. So using hypervisors, you can create a multiple virtual machines, multiple VMs, we call it virtual machines. Let's imagine this is one virtual machine created with the help of hypervisor on top of this hardware. So while creating a virtual machine, you can allocate the hardware. Let's say this is the capacity of your physical host, this physical host or a bare metal host, host or server. So while creating virtual machine, you can allocate maybe for this machine, you can allocate maybe 8 CPU, or maybe you can allocate based on your requirement 4 CPUs, maybe 8 GB memory. This is the capacity of the physical machine or a bare metal machine, host machine. And while creating a virtual machine on top of this physical machine, you can allocate some kind of a hardware with the help of hypervisor. Now this virtual machine, again in each virtual machine, again you can have an operating system. Again you will have an operating system. So each virtual machine, in each virtual machine you can have an operating system, complete operating system. Here again you can have a OS, operating system. In this virtual machine, in that OS, again you can install required softwares and configurations. In this OS, in this system, again you can install required softwares and configuration, and you can deploy your application here. Now let's say this is one of the virtual machine. This is one virtual machine created on top of the physical machine. And while creating a virtual machine, you have allocated some resources. This is the hardware resources you allocated to this virtual machine. Now you still have a resources in this, right? So out of 32 CPU capacity, you created just one VM with 4 CPU. Out of 64 GB capacity, you created one VM with 8 GB memory. Still you have a resources. So you can create a few more virtual machines like this. You can create a few more virtual machines like this in this system. So you can create a few more virtual machines. On this hardware, you can create a few more virtual machines like this. This is another virtual machine created on top of this physical machine. So on top of this physical machine, with the help of hypervisor, you created a, this is one more virtual machine. So based on the software or application you are planning to run in this machine, you can allocate maybe for this one 16 GB memory, maybe 8 CPU, maybe for this, maybe for this system, based on your requirement of the application or software running here, maybe you can allocate whatever, maybe 8 CPU with the 24 GB memory, like that. Suppose if you still have a capacity, you can create a few more virtual machines. Now each virtual machine has its own operating system like this. Based on the capacity of the physical machine, you can create like this more virtual machines on top of that physical machine. Now here again 8, 8, 16, 16 plus 4, 20. So you have till some CPU. Let's imagine 12 CPUs are available. You can allocate completely 12, or maybe you can allocate again 8 remaining again for one more system, like that. So 24, 24, 48, 48 plus 8. So here we don't have a 28. Again, let's say 16. So like this, you can create a more virtual machines on top of the physical machine with the help of hypervisor. Now, here each virtual machine has its own operating system. Now understand the application deployed in this virtual machine, the application deployed in this virtual machine in this OS, if this is causing some issue in the user area, process area, network area in this OS, in that kernel, is it going to impact the application that is deployed in another virtual machine? Suppose this application is causing in this OS, is it going to impact the application running in another virtual machine in the another OS, like that? No, you are isolating. You are isolating. You are isolating like an individual instead of a same OS, different OS, different application. So you are isolating. So here each virtual machine has its own operating system. In that virtual machine, you can install required softwares and configurations, and you can deploy whatever application or software here. Applications running in one VM is not going to impact the applications running in another VM because they are running in a different operating systems. So different operating system. So what is the advantages of this virtualization, virtualized deployment? In 1999 or early 2000, in early 2000, this virtualization, this hypervisors and virtualization concept came into the picture. It is very big revolution. It is very big revolution in IT industry, right? So this virtualization concept came into the picture in early 2000. Right? So what is the advantages of this virtualization or a virtual machines concept? Are we able to utilize our hardware resources or a system resources more efficiently without wasting also? Yes. We are utilizing our hardware resources or a system resources more efficiently without wastage. We are not wasting anything. We are able to utilize our hardware resources more efficiently. Again, here we have a different types of hypervisors: type 1 hypervisor, type 2 hypervisors, like that. So as part of our DevOps with AWS regular program, this I have already explained when I was explaining about cloud like AWS, right? Physical machines, virtual machines, like that. So here we have a two types of hypervisors. One is type 1, another one is type 2. software-based hypervisors, hardware-based hypervisors. Software-based hypervisors, hardware-based hypervisors. So type 1 is like a hardware-based hypervisor. That hardware itself, this hardware itself, like we have Citrix hypervisors, we have VMware, Citrix Zen, VMware servers, Citrix Zen servers, that physical servers, bare metal servers, that infrastructure, that hardware itself comes with hypervisor capability. So in case of hardware based hypervisors or basically type 1 hypervisors, we don't need any OS here. We don't need any operating system here in case of type 1 hypervisors or hardware hypervisors. Here we don't need any OS. In case if it is a type 1 hypervisors, hardware hypervisors, example Citrix Zen, VMware ESXi servers, or these type of servers. So we don't need any OS. That hardware itself comes with this hypervisor capabilities, and using on that hardware directly you can create a virtual machines. In that virtual machines you can have a OS, but you don't need a OS here in order to create a virtual machines. In case of type 1, example Citrix Zen, right? VMware ESXi servers, like that. But there is something called type 2 hypervisors. They are like a software based hypervisors. They are like a software based hypervisors. Software based, which means in case of type 2 hypervisor, you need a OS here. In that OS, you have to install that hypervisor software. In that OS, you have to install hypervisor software. In case of type 2, you need a OS here, and here that is the software based hypervisor, type 2. Then using that type 2 hypervisor or a software based hypervisor, again you can create a virtual machines in this machine again. So suppose even when you are using your personal laptops or a desktop, in your personal laptops or a desktops also, with the help of type 2 hypervisor, within your local laptop or a desktop also you can create a virtual machines, or maybe any other remote machine in any other remote servers also, using this type 2 hypervisors, again you can create a virtual machines within your OS. Examples for this type 2 hypervisors, which you guys are familiar, maybe you might use the Oracle VirtualBox, VMware Fusion, VMware Workstation, those type of softwares that you can install within your systems, and you can create a VMs within your systems, like again within that OS. But whether you are using cloud, whether you are using cloud like AWS or Azure or GCP, whether you are using on-premise environment, this hypervisors concept is same. So if you are using cloud like AWS or Azure or GCP, whether you are using on-prem also, we are not going to have a type 2 hypervisors. That hardware itself comes with hypervisor type 1. So whether you are using cloud like AWS, Azure, GCP, or whether you are using on-prem also, you have a type 1 hypervisors. So in case of AWS also, what we have created that EC2. Suppose in Azure VMs. Suppose in GCP Compute Engine, we call it that. So whether you are using on-premise environment or a cloud environment, you are creating a servers. They are like a virtual machines. They are like a virtual machines created on top of the physical machine. Using type 1 hypervisors only, they are going to work. So that EC2 instance, that we have created in AWS also, virtual machine, right? Suppose an on-prem also virtual machine. But in case of cloud like AWS, Azure, GCP, on-prem also, we are going to have a type 1 hypervisor. We already discussed in AWS, they are using Citrix Zen and AWS Nitro hypervisors. In AWS, they are using Citrix Zen hypervisors, that hardware, or AWS Nitro, right? But here, what is the difference between on-prem and cloud here? Suppose if you are using cloud like AWS or Azure or GCP, we don't need to purchase this physical servers. We don't need to worry about purchasing this infrastructure. In case of cloud like AWS or Azure or GCP, we don't need to purchase this hardware. We don't need to worry about this hypervisors or hardware. We don't need to worry about cooling system, power supply, the data center setup. They are managing the infrastructure. They have the data centers. This Azure, GCP, AWS cloud, they have their own data centers and they have the hardware in their data centers. We are just using their infrastructure. We are just using their infrastructure and creating a servers, virtual machines on top of their physical machines like that. But if we are using on-prem, as a company, we are responsible for purchasing this hardware or servers, and we are responsible for setting up the data centers, cooling system, power supply to that hardware. Then you are creating a virtual machines on top of your hardware. But this is how the physical deployment, virtualization or a virtualized deployment works. So far, we deployed so many applications as part of the DevOps with AWS program completed course. We built and deployed so many applications. Manually, we built and deployed using CI/CD. We have built and deployed. So we followed only this model, virtualization. You created a virtual machines and we deployed. Again, this is just one physical server, but in cloud like AWS or Azure or GCP, similarly you have so many physical servers, and your servers are distributed. Again, your servers are distributed to different physical servers like that, not in the same physical server, right? But what is common here for all the virtual machines? What is common for all the virtual machines that is created here? The hardware. In case of hardware failure only, this is going to impact, this is going to impact, this is going to impact. But in case of software issues, in case of OS issues or software issues, so only this is going to be impacted like that. So this is a virtualization or a virtualized deployment. So we have some advantages also. We have some advantages also with this virtualization, virtualized deployment. So advantages is we are able to utilize our hardware resources more efficiently, and each virtual machine is isolated from other virtual machine like that. But all the virtual machines are using the resources like sharing. They are sharing the resources like CPU, memory, storage from this physical machine. That hardware only common, rest everything they have their own. But here we are able to utilize our hardware resources more efficiently, but still here also we have some drawbacks. Here also we have some challenges. So that is where this containerization came into the picture in early 2012, in early 2012 and 13. In early 2012, the concept of containerization came into the picture. The concept of containerization came into the picture. So in early 2012, 13, the concept of containerization. So what are the challenges or drawbacks with this virtualization? So here we have some challenges. What do you think the challenges? Here, virtual machines are heavyweight. Each virtual machine, each virtual machine has a full OS, complete OS. That OS itself is going to take lot of resources again. Suppose each virtual machine has its own OS. So out of whatever resources you have created, allocated here, most of the resources will be taken by the OS only, right? Rest whatever is available, that is only available for your application. Virtual machines are heavyweight. Heavyweight means each virtual machine has its own OS, so that OS itself will use most of the resources given to that VM. Again, virtual machines are heavyweight. And again, virtual machines are slow means deployment is slow. Suppose in order to scale in scale out, or in order to deploy any new application, in order to scale in scale out, or in order to deploy any new application, virtual deployments are slow. Virtual machines are slow means what do you mean by virtual machines are slow means that application is not slow, the deployment process is slow. Suppose you wanted to deploy new application, again you create a new VM, again you create a new virtual machine, again you create a new virtual machine here, and again you have to set up the OS, and again you need to install the required softwares and configurations again. Finally, then only you can deploy the application. So virtualization or virtualized deployments are slow. Slow means in order to deploy a new application or in order to replicate, in order to scale existing application on another replica. So again, you create a new VM. The VM creation will take up to 2 to 5 minutes. Again, you need to boot the OS. That will take 2 to 3 minutes. Again, you need to configure the required softwares and configuration. Without that, you can't directly deploy this application. So this virtualized deployments are virtual machines are slow. One is heavyweight. Virtual machines are heavyweight. Virtual machines are heavyweight and virtual machines are slow. What do you mean by heavyweight? Means each virtual machine has a OS. That OS itself consumes a lot of resources given to that VM. Rest only available for your applications, right? And again, slow means in order to scale or replicate the application, you need to create a new VM. In order to deploy new application, different application also, you need to create a VM. So creation of VM, installing and configuring the required softwares and configurations, and finally deploying the application. Even though you use automation, configurations, automation also, it will be slow, takes time. One, that is one more problem. Again, you can automate this also instead of manually configuring this applications or softwares. Instead of manually deploying this application, you can speed up using some tools. You can use configuration management tools like Ansible, and again build and deployment tools like CI/CD. But here still we have some problem. One more problem here is maybe if you are using virtualized deployment, whatever application you have deployed in one system, maybe same application, whatever application you have deployed in one VM, whatever application we have deployed in one VM, the same application you try to deploy in a different server, different VM. Maybe you deployed that application in a dev servers. Same application, if you try to deploy in a production server or a QA server, sometimes it may not work, even though that application package is same. So sometimes you may observe these type of issues, whether you are a developer, whether you are a DevOps guy, whether you are a tester. This is common problems you may observe. Suppose the developer will build and deploy the application in his local system, it will work. Maybe same application code you have taken and deploy in dev server, it may work. But same package, same application package, again you go and take and deploy in a production server or a QA server, it may not work. So this is a common fight. Developer will say, I don't know what is the problem. Same application I have deployed in my local laptop or a desktop, it is working fine. And same package only have deployed in dev server, it is working there also. But I don't know why it is not working in QA staging like that. So here, this is one more problem. So what do we think? What do you think? What are the challenges, or what do you think? What are the root cause? What do you think? What is the root cause for these type of issues? Inconsistency. That application is not consistently working in different servers. Maybe in one server that application may work, in another server it may not work. What do you think? What could be the root causes or issues for these type of inconsistency in the application? Same package, same code, work in one server, may not work in another server. That is because of maybe different hardware, I mean it's a different software configuration. Maybe let's imagine, while deploying that application in dev, you have properly installed required softwares and proper version. Let's say this application requires Java 11, you might have installed Java 11. And this application requires Tomcat 8.5, you might have installed Tomcat 8.5. And also you may need to update some settings file. You have updated all the settings, and again you have to set some environment variables, you have set properly. But same code if you take and deploy in QA server, maybe here, maybe you have not installed the same Java 11, but application is expected to have a Java 11, but here you have installed maybe Java 9. Maybe even though you have installed Java 11, even though you have installed Tomcat 8.5, maybe you have not updated the required configurations or settings, or you missed to set the environment variables. If you do these type of things again, missing, again, same package may work in one server, may not work in another server. That is one more problem. That is one more problem. But here, Again, you can overcome this by creating a machine images. Suppose if you already know cloud like AWS or on-prem also, we have something called machine images, ISO images. So you can completely create a machine image with the OS, required softwares and configurations and applications also. We call it as a AMI, machine images. In case of AWS, we call it as a AMI, Amazon machine image. So you can create a machine images and you can create a machines from that machine images. But again, the base problem is same. That is also a VM heavyweight. OS itself will take lot of CPU memory and rest only available. So we have some kind of a challenges or a drawbacks with this virtualized deployment also. Like virtual machines are slow, virtual machines are heavyweight, virtual machines may have some kind of a consistency problem. We have some challenges or a drawbacks with this. So this is where again one more one more new technology came into the picture, that is containerization technology. The way we have a virtualization technology, this is where again the concept of containerization technology came into the picture. So here the containerizations is bringing isolation to the next level. The containerizations are bringing isolation to the next level, OS level isolation. So here this hypervisors virtualization is bringing the isolation to the hardware level, but using containerization tools. Using containerization tools, we are going to bring isolation to the next level, OS level. We are going to bring to the OS level. OS level, you are going to bring an isolation here now. But how? How that is possible, right? So how that is possible here? Let's imagine this is again, this can be a physical machine or a virtual machine, that doesn't matter. Using containerization technology, you are bringing isolation to the next level, OS level isolation. So here we are going to use some containerization tools. We are going to use some containerization runtime, containerization tools, containerization software. Here we are going to use some containerization tools or containerization softwares like Docker. Docker is most popular. Docker is most popular and widely used containerization tool. But Docker is not the only containerization tool. Similarly, Docker, we have something called Podman. Similarly, we have lot of things here. So using these containerization tools, again, you are bringing isolation to the next level. Even in the single OS, also, you can build and release your applications as a containers using this containerization tool. So using this here, even though it is a single VM, but with the help of this containerization or containerization tools, you can deploy multiple applications or multiple softwares as a containers here. But sir, you told last time in the same OS you can't deploy because you said something like kernel, user space, network space is there. But now how come you are saying in same system again you can deploy like this? You said in the physical deployment there is a problem, like there is a namespace, user space, network space. You can't run like that, you told here. But again now you are saying we can run multiple applications like this in a same OS. But here we have something here. This is software. This software is going to take care of isolation in the same OS. It is going to isolate each application, each process, or each application or each process from other process. So here using this containerization technology, using this containerization concepts, we are bringing isolation to the next level, OS level isolation. OS level isolation. So here in a single operating system, in a single OS also, we can run multiple softwares as a containers. So each container is nothing but some process. This can be database process, or this can be Nginx process, or this can be Tomcat process, this can be Python process, Java process, like that. So this is one container. This is another container. Container is nothing but it's basically one application or a program running inside that, basically process. Now you can run multiple applications or a containers here. This is like one container, container one, your application container, database container, or maybe microservices architecture. each microservice is going to run as a container. Again, like this, you can run multiple applications or a softwares as a containers in the same OS. But how it is possible? How there is an isolation now? So here we have something called containerization tool, containerization software. We have a containerization tool or a containerization software here. So each container is going to be isolated from other container in this OS, in the process space, network space, like that. So here, this containerization tools is going to allocate separate user space, separate process space, separate network space, separate storage space for this process, this container. Again, the same containerization tool will allocate, it is going to allocate separate user space or a process space, network space in for this container in this OS. So each container will get its own process space, network space, storage space, like that. So they are isolated in the OS kernel. They are isolated in the kernel by each container will get its own process area, network area, storage area, user area, like that. But who is separating? Who is isolating this? Who is allocating that process space, network space, storage space for this? This containerization tool is going to make sure each container gets its own process space, network space, storage space, like that. So because now they are isolated from each other in the same OS, in a separate process space, network space, if this container is causing some issue in that process area, network area, storage area, the other container running in the same OS but in a different process space, network space, storage space is not going to be impacted. So the isolation being, came to the next level. This is like a OS level. This containerization is doing OS level isolation or a software level isolation. But these hypervisors are doing hardware level isolation. Hardware level isolation. So now let me make this as a separate diagram so that you can understand. So now this isolation came to the next level. In this this isolation came to the next level. Now let me delete and make this so that you will understand the differences in virtualized deployment, physical deployment, traditional deployment, like that. So now these containerizations are bringing isolation to the next level, OS level, OS level, OS level. Now this is how the virtualization is working. But now here, whether this is a physical machine or a virtual machine, that doesn't matter here. This is a physical machine or a virtual machine, that doesn't matter. OS level isolation came here. OS level isolation came here. So now this is again your hardware. This is your hardware. This can be a physical machine or a virtual machine. In single OS, multiple applications as a container. Each container is isolated from other container. But here, containers are lightweight. Containers are lightweight. Why they are lightweight? Containers will not have a OS. Containers will not have a complete OS. So containers are lightweight. Lightweight means containers will consume very less system resources because containers will not have a OS. Because all these containers, whatever we are created in this system, so this OS, this container also will use this OS, this container also use this OS, this container also will use this OS. So what is common for all the containers that is created in a particular system? That system OS, that system kernel, that host machine kernel, that host machine means on whatever machine you have created a container, that is called as a host machine. So this is OS. This container also will use, this container also will use, this container also will use. So containers are lightweight, lightweight because the containers will not have a complete OS. They will just have a OS libraries to interact with this kernel. They will not have a OS. So it will just consume less CPU, less memory. Because containers will not have a OS, containers will be using this host machine OS, this host machine kernel. So that's why containers are lightweight. And again, containers are fast. Fast means you can quickly deploy more containers. Quickly deploy more containers. Again, using containers, right? Using containerization technology, With the help of a Docker file, we will understand all these things in a regular sessions. With the help of Docker file, you can create an image with not only application code, you can build a container image. You can build an image with you can create a package with the required softwares and configurations, and you can create a required softwares and configurations along with your application. So with the help of Docker file, in case of Docker, if you are using Docker, with the help of a Docker file, we will discuss about what is Docker file, how to build the images with the required softwares and configurations. We'll understand. But first, understand the high level components. Why this Docker came into the picture, what type of challenges or problems this Docker is trying to solve. That is very, very important. So with the help of Docker file, using Docker, you can build a package. You can build a package. This is also a package. The way we have a tar file, zip file, RPM file, Debian file, we call this package as a Docker image. So you are going to build a Docker image. Basically, it's a package with required softwares, configurations, application, but no OS. So this package will not have a complete OS, just OS libraries to interact with kernel. That's it. So you are going to create a package like this, and these packages again you can store in the artifactories. You can store these packages in the artifactories. You can store these packages in the artifactories. You can store these packages in a central place. And wherever you wanted to deploy, if this application or a software as a container, so you no need to install application softwares, application configurations here. You just take this package, you just pull this package to this system and create that run that package as a container. So that container contains everything. So quickly you can build and quickly you can release your softwares or applications as a containers, because you are building a package, with required softwares and configurations, and you are storing at central place. So you just need to pull that package, and create that again as a container. That can be new application you wanted to release, or maybe existing application you wanted to increase more replicas. You just increase the containers, scale in, scale out. The way we can increase and decrease the machines based on the demand. Here, if you are running your applications as a containers, you can scale in, scale out the containers. If it is a new application, create a container out of a new image. If it is a old existing application, scale in, scale out. So here, containers are lightweight, containers are fast. Containers are fast means you already created a package with required softwares and configuration. You just take that package with the help of this software. You run that package as a container. So that application will be up and running in that system as a container. Again, each container is isolated from other container, like that, in the same system. So containers are lightweight, containers are fast. Again, here we may don't see that environment inconsistencies. If that application is deployed as a container, if it is working in one system, if that application is deployed as a container, if it is working in one system, if that application is deployed as a container, if it is working in one system, that is going to work in the other systems also, because your same package, not only application package, your softwares, configurations, environment, everything is same. Suppose you created a Docker image and this you deployed in one server, you deployed that in one server. If it is working fine here, maybe same software you are trying to deploy in a production server. Again, let's imagine this is your production server. So there also same package, same softwares, same configuration. You don't see that environment inconsistencies, environment problems also. You don't see that again, environment inconsistencies, environment problems. You say pull the same package and create that as a container, so that if it is working in one system, it will work in other system, which means this containers will work wherever there is a Docker installed. whether that can be a local laptop or that can be a server in on-prem, that can be a server in cloud, like that. So we can avoid that environment inconsistencies. So this is how the containerization evolved. This is how the containers concept came into the picture. Sometimes in the interviews also they will ask what is difference between virtualization and containerization, like that, and what are the differences between virtualization containerization. But here what is common for all the containers that you are created in this system, this OS, and again the hardware resources, that is allocated, that is available for this system. This container also will consume CPU and memory from here only. This container also will consume CPU and memory from here only. This container also consumes CPU and memory from here, and all these containers will again use the OS, same OS. But containers are quick, containers are fast, containers are lightweight. So that is the differences between virtualization and containerization. So here virtual machines are heavyweight, containers are lightweight. Heavyweight means each virtual machine has its own OS, but again containers also runs on VMs only. Containers also runs in the VMs only, but instead of directly running your application in the VM, you are running that application as a container using containerization technology. Container multiple applications also you can run as a containers, right? So virtual machines are heavyweight, containers are lightweight, and here each VM has its own OS. But here all the containers running in that system as a containers, all the applications running as a containers in the system, they are going to use the same OS. This virtualization or a virtual machines is doing hardware level isolation, but this containerization is doing OS level isolation. So containers can be quickly started. Within seconds you can make your application up and running as a container if you have a container images. But in case of virtualized deployment, virtual machines are slow means you need to set up a new VM. If you are directly deploying in a virtualized deployment, again install the required softwares and configuration, again deploy that application and make that application up, it takes time. Again, when you are creating a virtual machines, you are going to allocate the CPU and memory, but containers will consume less CPU, less memory, whatever is there in the system. But here virtual machines are fully isolated, more secure, but containers is a process level isolation, not a hardware level isolation. This is like a OS level isolation or a process level isolation. Less security, less secure, but by using some kind of a best practices, when you are running your softwares as a containers also, you can secure your systems and you can secure your containers also. We'll discuss about that. So this is the difference between virtualization, this is the difference between virtualization and containerization, right? This diagram is going to just give overview. Virtual machines heavyweight, huge in size. Containers are lightweight. Containers will take very less CPU, less memory. In the in the perspective of size, containers are very fast. You can quickly start your applications as a containers. But if you are using virtualized deployment, virtual machines are very slow, like a tortoise. It takes time to create a VMs, deploy, install, like that. Now virtual machines are slow, containers are very fast. And integration between the applications running in a VMs is a little difficult, but containers to container integrations is easy. So this is just with respect to size, speed, and integration. So this is the difference between virtualization and containerization. Now, Docker is a one containerization software. So Docker is one containerization software now. So Docker is a containerization software which will allow you to package. It will allow you to package your application and all its dependencies together in the form of containers, so that your application will work seamlessly in any environment, whether it's a dev, whether it's a testing or a production. So again, Docker is a open source platform for developers or DevOps guys to build and ship and release applications. So in a detailed way, what is Docker, right? Why Docker is required again, what are the advantages of Docker and how to install Docker, Docker architecture, Docker flow. The Docker flow means so for your application, with the help of a Docker file, we can build a image. These images you can store in the registries. Then you can take that image and apply. So this Docker flow, right? Docker image, containers, networks, all these content we'll try to discuss in a detailed way from next session, right? So here, today's session is like what we are going to cover as part of this Docker and Kubernetes, that syllabus, and also introduction to the Docker, why Docker came into the picture, right? In the previous, what is a physical deployment or traditional deployment, what challenges we had, then what is that virtualization or a virtualized deployment, now containerization or a containerized deployment. With this background, if you learn Docker, then you will understand Docker. But without learning all these things, if I directly go and say install Docker like this, create image like this, you don't understand why Docker came into the picture first, what type of challenges or problems it is trying to solve, right? So from here, I'll continue in the next session. Today, I mean to say tomorrow, I am not taking session. Tomorrow, I have some, puja in my home evening. I am not able to take the session tomorrow. Tomorrow, I am giving a break. Then we are going to start from day after tomorrow. Okay? So day after tomorrow, we are going to start the actual Docker. The actual Docker we have not started. So day after tomorrow, we are going to start Docker. Today, we just discuss about containers versus virtual machines. Later, we will understand benefits of Docker, what is exactly Docker, how to install Docker, all these components. I hope everyone is clear about what we are going to discuss further. And again, already, what is virtualization, what is containerization, what is traditional deployment, physical deployment. Already I have uploaded one video in our YouTube channel. This is our YouTube channel, right? You can go and search in Google also, Rushi Technologies. You may see this. So here I already uploaded one video, like here, virtualization versus containerization. This video I am talking about. Same thing today also I have explained, but if you want, you can refer this also one more time, right? Similarly, right, we have some few more Kubernetes components, but not all the concepts are uploaded here, only few components, right? So if required, you can go through this virtualization versus containerizations also uploaded already here. Their same whatever I have explained today, this is also covered there. So from here, I'll continue day after tomorrow. Tomorrow no session. You guys can utilize the tomorrow and you can go through that session. And from here, I'll continue day after tomorrow. If you guys have any specific questions or any specific queries, feel free to unmute and feel free to ask me, guys.
Sir, is Docker still supported in Kubernetes?
Yes, yes,
Okay,
yes,
okay.
yes. I will explain about that. Basically, you might heard news like Kubernetes deprecated Docker. You might be thinking, so Docker is gone, Docker is dead. It is not like that. So whatever images you are building using Docker, still that is compatible with Kubernetes because everyone is defining some standards. There is something called OCI, Open Container Initiative. It is like a set of standards and guidelines defined by containerization technology tools. Everyone has to follow that standards when they are building the images. So even Docker also followed that standards, so that Kubernetes is still compatible with that Docker images because of the standards that they have defined and followed. So still Docker is more powerful, even though in Kubernetes they said Docker deprecated, but still Docker is more powerful. And now again Docker is compatible with Kubernetes because again they have developed some plugin CRI Docker D. So now still you can use Docker also in Kubernetes nodes. It is compatible. That we will discuss in further sessions.
Okay, thank you, sir.
And here, whoever is only enrolling for Dockers and Kubernetes, right, you can reach out to me on this number. I will share further details with you. And if you enroll for this Dockers and Kubernetes, right, you can enroll maybe before next session, so that you guys will get the meeting links and other from next session onwards. So you can reach out to me on this number if you are only looking for Dockers and Kubernetes, whoever joined today, only for Dockers and Kubernetes. Thank you guys. That's it for today. From here, I'll continue. Day after tomorrow no session. Okay, I'll continue day after tomorrow and utilize the tomorrow break to go through this what is virtualization, containerization also, and go through the curriculum so that you will get a complete idea. Thank you guys. That's it for today. See you day after tomorrow.